Dear students, let's learn about the new chapter, current electricity. Very important chapter because this particular chapter has the maximum weightage from the board exam point of view. So, you consider this circuit. So, here we have a battery, then we have a switch over here, then there is a bulb. Now, first, in any circuit, we always need a battery, or we also call it as a source of EMF, and this battery will provide you the potential difference. After that, a switch to close or open the circuit, and when you close the switch, and obviously we need a device so that we can verify the flow of the current, so for which we have connected a bulb. And now when the switch is closed here, see when the switch is closed, so what happens? The electron will start flowing through the bulb. So imagine if this is the positive end and if this is the negative, if this is positive and if this is negative, the electron will always flow from negative to the positive terminal. Okay. Remember, the electrons will always move from the lower potential to the higher potential like this. Okay. The electron will start flowing, and when the electron starts flowing, this particular bulb will start glowing. So, that is what happens when you switch on any of the devices, the charges will start flowing through it. So, what are the two conditions which are very much essential for the flow of charges? Point number one, you need always a potential difference, and most important, a closed path. So, without the closed path, there cannot be any flow of charges, and that flow of charges will result in a quantity called electric current. So, that is what we are going to learn, and all about the current in this particular chapter. So, the first question is how to define electric current, or what is electric current? If total Q amount of the charge, total charge, okay, Q, flows steadily in a circuit in a time t, then electric current is defined as a rate of flow of charges. That means charge divided by time. So, how do we define electric current? Rate of flow of charges. So, rate of flow means how fast the charge moves in a circuit, and which charges actually flows. In reality, it is always the electron that moves, and whatever the current that exists, or whatever the device, if it all it works, then it is because of the flow of the electron. It is because of the same flow of electrons through our body we experience as electric shock. So, whenever we feel electric shock, there is a potential difference between the switch or the plug which we are holding and the other end of our body, which is to the ground. There is a potential difference, and we are the path for the flow of the charges. What kind of charges flow? Electron flows through our body, which we cannot resist, and that is why we experience that shock. And if a large amount of the charges flow, so our body start reacting to it, correct, and then we may even die. So, that is depends on how strong that current is, or how high the voltage that is developed across our body. So, I am sure you must have experienced in your life at least once what is electric shock means. Okay. So, therefore, that shock is nothing but flow of the electrons through our body. Okay, right. So, the first point, that is definition. What is the definition? A rate of flow of current, rate of flow of charges is called electric current. Now, what is the SI unit of it? The SI unit is, see, the charge is measured in terms of the coulomb, and the time is measured in terms of the second. So, which we can write it as a coulomb per second. But you know the basic unit, because some of the physical quantities are given some basic unit. So, definitely the unit of electric current is a coulomb per second, but that is the equivalent of an unit called ampere. So, ampere denoted by capital letter A is the SI unit of electric current. So, instead of writing coulomb per second, we write ampere. 2 ampere, 2 is the magnitude of the current and ampere is the unit of it. Now the next question is whether it's a scalar or a vector quantity. Charge is a scalar, time is a scalar, that's why electric current is also a scalar quantity, it is not a vector quantity. Current due to an electron. See, whenever an electron revolves in a circular path like this, when it moves circular path, okay, and if it completes n revolutions in a time t second, if it completes n revolution in a time t second, then the total charge that is flowing through this will be n into t. Okay, so total charge will be correct. So n revolutions, n number of revolutions here, correct, n revolutions in a time t second. Okay, so the total charge will be n into charge of the electron, okay, not n into t, n into e is the charge of the electron, correct. So therefore, how to define current now? So current is given by I is equal to q by t, correct, and that q is nothing but n into e by t. So this is the formula to find the current due to an revolving electron, okay. So what is the total charge? Total charge is number of revolutions completed by the electron, right. So that's why you have to multiply by e, where e is the charge of the electron. So therefore, the total charge that is revolving in that circular orbit is nothing but n into e. Therefore, I is equal to q by t, which is n e by t, is the electric current due to a revolving electron. How do we measure the instantaneous current? See, in some of the circuit, the current continuously changes with the time. For example, the alternating current. The current that flowing through all the devices, home appliances, is nothing but alternating current, and which changes continuously. And whenever the current is a variable, we always measure current at a particular instant of time, and that current is called instantaneous current, which is measured by I is equal to, instead of writing q by t, we write I is equal to dq by dt. That is a small amount of the charges flowing steadily in a time dt. So this we use it for a steady current. This equation is used to find the steady current, okay. This is used to measure the instantaneous current. So hope you have understood about the basics of the current. So we are going to learn more about it. So let's continue with that. Now, whenever electron moves through a conductor, whenever they move through a conductor, so let's consider a conductor in the form of a cylinder like this, and here we have a potential difference, which is very much essential. Only then there will be flow of charges, and inside this conductor an electric field will be developed from positive to negative. This is the direction of the electric field, and L is the length of the conductor, A is the area of cross section. And now the electrons, as I have told you, always move from negative to positive, low potential to the high potential. Therefore, the electron will move in a direction opposite to that of the electric field, okay. This will flow opposite to that. Now, as it moves, as the electron moves, this is a conductor, so it's a dense matter. There are plenty of very closely packed atoms are there. So therefore, as the electron moves like this through the conductor, it will get collided, with the other atoms or the electrons, and due to collision, its path continuously changes like this, okay, and then finally it reaches the other end. So there is a change in the direction of the electron, there is a change in its velocity as it moves from one end to the other end. And since the velocity continuously changes, we can always calculate the average value with which it is pushed, with which it is drifted. And that average velocity with which the electrons are drifted is drifted here, okay, under the influence of the electric field is called as the drift velocity. So what is the definition of the drift velocity? The average velocity with which the electrons are drifted in a conductor under the effect of electric field is called as drift velocity. So what is drift velocity? The average velocity with which the electrons are drifted in a conductor under the effect of electric field is called drift velocity. Again, important definition, you can see it has appeared 4 times in the examination. So, hope you have understood what is drift is. So, drift is nothing but the push the electron gets as it under the influence of the electric field. There has to be some potential difference without which the electrons doesn't move from one end to the other end. Okay. Then as it moves, it's get collided, right? It gets collided. Now during the successive collision, what is the time it takes? Suppose if it collides to one of the atom and then it rebounds and again it collides with the one more atom. So during this, there is a time during which it doesn't collide, correct? And that average time interval between the two successive collision is called as the relaxation time. So, what is the relaxation time? The average time interval between two successive collision suffered by a free electron in a conductor is called as relaxation time, and it is denoted by a Greek alphabet tau. So, what is the definition of, again important definition. So, what is the relaxation time? The average time interval between two successive collisions suffered by a free electron in a conductor is called as the relaxation time. So, as it moves from one end to the other end, we can always calculate the drift, which is called drift velocity, denoted by Vd. We can even find the relaxation time, which is tau, the average time interval between the two successive collision, and then as it moves like this, it will move in an enclosed path that will result in a current, and we can find the expression for drift velocity, we can find the expression for electric current in terms of drift velocity. So, that is what I am going to explain next. So, expression for drift velocity in terms of the relaxation time. So, first let us consider a circuit. So, look at the circuit. So, V is the potential difference, E is the electric field, which is always from positive to negative. Direction of the electric field is from positive to negative. Electrons will move like this, from negative to positive. Electrons will always move in a direction opposite to that of the electric field. Okay. And as they move, they collide continuously, correct? And that is called the drift velocity. The average velocity with which they move is called as drift velocity. So, first let us calculate what is the force experienced by this electron. The force experienced by the electron is F is equal to E into E, okay, with a minus sign. Minus sign indicates that the force and the electric field are opposite. Electric field is to the right, whereas the force is to the left. F is equal, and this F is nothing but mass into acceleration, which is minus E into E. So, therefore, what is the acceleration experienced by the electron? It is minus E by m. And we know that the velocity is given by V is equal to U plus A, and then the average time interval, which is tau, relaxation time, or we can even write here V naught, okay, which is the initial. But after colliding, again it starts with 0 initial velocity. So, once it collides, correct, from there again it starts with a 0. That is why the average of this particular value is a 0. What is the value of acceleration? Acceleration is given here, which is minus E by m into tau, and this velocity is called as the drift velocity. Therefore, there we are with an expression for drift velocity. Vd is equal to minus E tau by m. So, what is the expression for drift velocity? Vd is equal to E tau by m, and if you want the magnitude of it, then it will be E tau by m. Okay, let us identify the various terms. What are those terms? First one, what is capital E? Electric field. What is small e? Charge of the electron. What is tau? Relaxation time. What is m? Mass of the electron. Okay. So, what is the expression for drift velocity? Vd is equal to E tau by m. So, again an important question. So, it is a 3 marks derivation here. This is force is equal to field into charge, force is equal to mass into acceleration, we get the acceleration. This is from the first year equations of motion, V is equal to U plus A into T. Here T is nothing but that average time interval between the two successive collision, which is the relaxation time, and this is the average velocity, okay, due to the thermal motion or the initial average velocity, which is always 0 here, and that is how you get Vd is equal to minus E tau by m. We can even calculate the expression for the current. So, I am going to consider the same circuit again. So, first let me take some variable small m. Now, small m stands for number of free electrons per unit volume, or it is also called as a free electron density, number of free electrons per unit volume or free electron density. So, if n is the number of free electrons per unit volume, then what is the total volume of the conductor? The total volume of the conductor is A is the area of cross section into the length, AL is the total volume. So, now what is the total free electrons? So, total free electrons is nothing but number of free electrons per unit volume into the volume will give you the total free electrons. If E is the charge of every electron, then the total charge of free electrons, okay, is, I am going to use this as a Q, which is NaL into E. So, that is the total charge. Now, when the electron moves, okay, the distance they cover is L with the average drift velocity Vd, and if a small t is the time taken for it, then velocity is equal to distance by time, or time is equal to distance by the velocity. So, now we know the total charge, which is Q, we know the total time taken for it, and now I can find the current. So, current is equal to charge by time. Charge is NaL into E by, what is the time? L by Vd, So, L will get cancelled. So, we will get I is equal to NaEVd. Here it is. So, this is expression for electric current through a conductor, where N is number of free electrons per unit volume. It is also called as a free electron density. It has a unit, because it is a number of electrons by volume. So, per meter cube is the unit of it, number by volume. So, this has a unit. A is the area of cross section, not the total area of the conductor, only the area of cross section of the conductor, which is a circular in this case. E is the charge of the electron, which you all know, magnitude 1.6 × 10⁻⁹ coulomb, and Vd is nothing but the average velocity, which we call drift velocity. Drift velocity has one more formula, as you all know, Vd is equal to its E tau by m. So, one expression for Vd is this, I by NaE. From here, Vd is equal to I by NaE, or Vd is equal to E tau by m. Okay. So, this is also an important question, even though it has not appeared in the examination. So, they may definitely ask this derivation, because they have asked to write the expression for electric current. They have not asked the derivation of it, but definitely they have asked to write the expression for electric current in terms of drift velocity. So, that was the question asked for 1 mark in the examination. So, hope you have understood both the derivations of it, okay. And based on this, let us define two terms. So, first I am going to write an expression for current, that is one is Vd is equal to E tau by m, and the other is I is equal to NaE Vd. Okay, so these are the two equations. Based on this, I can define two terms. First one is mobility, which is Vd by E. Vd by E. The symbol used for that is mu. Okay, so you can see the definition appeared 5 times in the define the term mobility. So what is the definition? Definition is mobility is defined as the drift velocity per unit electric field. See, drift velocity per unit electric field is called the mobility of the free electron. So what are the SI unit? There are two units are there. See, one, drift velocity I can write in terms of meter per second. Meter per second. Electric field, it's Newton per Coulomb. Newton per. But Coulomb per second is nothing but ampere. So that's why ampere meter per Newton is the unit of mobility. There's one more unit, drift velocity, meter per second. The unit of electric field is also volt per meter. Okay, volt per meter. Therefore, the unit is meter square per second per volt. This is the another unit. Any one unit you can write in the examination, and this unit is a one mark question from one of the exam. Clear? So, two units of mobility. So, how do we define mobility? Mobility is defined as the drift velocity per unit electric field. Symbol used for that is mu. That means greater the drift velocity, greater is the mobility. The electron can. What do you mean by mobility? How easily the electron can move through the conductor, correct? So, greater the mobility means they can move more easily through the conductor, so that a large current flows through the conductor. Clear? The other term is this, current flowing per unit area of cross section. This is called current density. Okay, I by A. So, which you can write it as NEVD. That is the next term. That's current density. So, how to define current density? So, current density is defined as the current flowing per unit area of cross section. Current flowing per unit area of cross section. Current is measured in terms of ampere, area is measured in terms of the meter square, and that goes to the numerator. So, that's why ampere per meter square is the SI unit of current density. So, again one more question from the exam. Clear? And current density is a vector quantity. This is a vector, whereas mobility is a scalar quantity. So, hope you have again understood all the terminology that we have used in new chapter called electric current. So, we are going to learn more about it and more numericals on this particular topic in my next class. So, do start reading the chapter number 2. So, there will be an interactive session. After that, there will be a test soon. Okay, till then take good care of yourself. Thank you.